Hi class, this is lesson 8-4 in the textbook. It's all about rhombuses, rectangles, and squares. These are three different types of parallelograms, which are the shapes that we studied in our last two lessons. So the first one we're going to talk about is a rhombus, which is probably the most unfamiliar of the three that you've seen in your lifetime. And so here's a picture of what a rhombus looks like. As you can tell with the orange markings, a rhombus has the exact same length for every side. So what we're going to write for its definition is it's a parallelogram with four congruent sides. Okay, so it's pretty basic. So if you ever see a shape that's a parallelogram, you're told that, and also all the sides are congruent, then we can go ahead and say, oh, that's a rhombus. And I have a statement that I'm going to show you right here. It says that a quadrilateral is a rhombus if and only if it has four congruent sides. This can be said the other way as well. I can say that a quadrilateral has four congruent sides if and only if it is a rhombus. Okay? So why don't we go ahead and move on to our next shape, the rectangle, something that you've seen since kindergarten, if not beforehand. And as you can tell on a rectangle, all that we're told is that the four corners are right angles. So that's going to be the premise for our definition. A parallelogram with four right angles. And that's it. We're not told anything about the sides, the lengths of the sides, but we're told that a shape is going to be a rectangle if it has four right angles. So also I have a statement that we're going to add for a rectangle. And it says, a quadrilateral is a rectangle if and only if it has four right angles. Okay? This can be said backwards as well. A quadrilateral has four right angles if and only if it is a rectangle. Now you might only use these statements later on when we do proofs in class, but just keep these in your notes. The last one we're going to talk about is the square, the most basic shape that you've probably learned. And in this square, the purple markings are everywhere. There are markings to show that it has four right angles in every corner, but also it has markings on the sides to show that all of the sides are congruent. So, if you're looking at the two definitions that we have before for a rhombus and a rectangle, you'll kind of notice, hey, that's a little similar to what I know about a square. And that's what we're going to put. That a square is a parallelogram with four congruent sides and four right angles. So the statement that we're going to make is that a quadrilateral is a square if and only if it is both a rhombus and a rectangle. So if you've ever had any confusion before of someone saying, oh, I know, that square is a rectangle. Well, that's true, because the rectangle definition is only about right angles, and a square satisfies that. But the square also satisfies the definition of a rhombus with the four congruent sides. So keep that in mind. I just have three theorems for us, and then we're going to be done with this lesson. So first theorem is Theorem 8.11, and it says, a parallelogram is a rhombus if and only if its diagonals are perpendicular. So we're already told that it's a parallelogram, and we're shown that by the arrows again, shown that AD and BC are parallel, but also AB and DC are parallel. But we're told it's a rhombus only if we can show that the diagonals are perpendicular, meaning that they meet at 90 degrees. So I can say that A, B, C, D is a rhombus if and only if AC, that segment, that diagonal, is perpendicular to BD. Alright? Awesome. Let's go ahead and move on to our second theorem. It is Theorem 8.12, and it says, a parallelogram is a rhombus if and only if each diagonal bisects a pair of opposite angles. So again, when we see those statements, if and only if, that means it goes both ways, that I can start with the conclusion and lead up to the premise. So here again, I have a parallelogram as shown by the arrows. I actually have too many arrows, so we're going to show this has 3 arrows right here, just so we don't get those confused. And what this is saying is that the diagonal is actually bisecting that corner angle. So those angles right there are all exactly the same. And same with the other angles with the endpoints B and D, that those are the same, and those are the same because they're being bisected by the diagonal. So a statement that I can write here, and it's going to be a little bit longer, we can say that ABCD is a rhombus if and only if AC bisects 2 angles, BCD and angle BAD. And the other diagonal, which is BD, bisects angle ABC and angle ADC. Okay? Awesome. Let's move on to our third theorem, and then we're going to be done for the day. This is Theorem 8.13, and it says a parallelogram is a rectangle if and only if its diagonals are congruent. Okay? So in this case, I have my diagonals, and I need to show that they are congruent, which means that AC needs to be exactly the same as BD. So let's go ahead and just write that down. ABCD is a rectangle if and only if AC, so the diagonal going all the way across, is congruent to BD. If that's the case, I can say that it's a rectangle without even knowing that the corners are right angles. So it's pretty cool. So these are the only things that we're going to be learning in our lesson today. Bring them to class because it's going to help us to prove a lot of statements about just different shapes that we're given to see if they are rhombuses, rectangles, squares, or maybe a combination of some of them. So I'll see you when you come to class with any questions you have.